to show the current carrying wire produces magnetic field. So this is the case. The current and magnetic both are interrelated in this total experiment. We will see how they are interrelated. So how the electromagnetism has taken place. Let's proceed. So for this activity we required materials like thermocol sheet, 2 thin wooden sticks. So the top of the wooden stick should be some slits. Next, the wooden stick's height of 1 centimeter, copper wire, so it is 24 gauge, it is better. Next, 3 or 4 volts battery, key means switch, and magnetic compass. So these are the materials. Based on these materials we can perform the activity, the experiment. Let's proceed step by step. So procedure. Take a thermocol sheet and fix 2 thin wooden sticks of height 1 centimeter which have small slit at the top of their ends. So we already seen, we have taken a wooden sticks which have the slits. So some cuttings on the top. So this is the case. We have to take the thermocol sheet, and the thermocol sheet we have to place 2 wooden sticks which have the slits on the top of their ends. So the figure I will explain. In the figure total matter is there. So next, these sticks are joined with the help of the copper wire and a series connection with some more elements like battery, key as shown in the figure 1. So let's go to the figure. So in the figure I have taken it is a thermocol sheet I have taken, the one. Next, the parts I will explain later. Let's go to the diagram. So here I placed a thermocol sheet. Next, 2 wooden sticks I have placed on the thermocol sheet which have the slits. Slits means the bending. So it helps to connect. It gives the support for the connecting wires which holds the wires in a stable way. So this slits is the use that one to stable the wires. Next, with the help of these slits, we will connect one end to another end of the another stick. Next, these ends of the wires are connected one to the battery, and it made a series connection with the key or the switch. The another turn will be connected to the switch. This is the case. This is the total figure 1. See the parts I have taken. See 1 as the thermocol sheet. Next 2, it is wooden sticks. Next 3, it is the battery group of cells. Next 5, compass. We will see the compass. What is the need of the compass? Next 6, it is the key or the switch. Next 4th, it is the copper wire. With a magnetic compass step we have to see. See, place a magnetic compass beneath the wire as shown in figure 1. So the compass should be placed under the wire. So by using this placing of compass only, we will conclude that the current and the magnetic both are interrelated. So we have to place the compass under the wire. Next, without making key to on, just before check the needle in the compass, we can notice that no deflections in the compass. So before on the key, just see the compass. What is the position of the needle? The needle will be no more deflections. Means the needle is in stable state. There is no movement in the needle in the compass. Let's go for next point. Now press the tag key, means switch on, and allow the current through the wire. It is observed that magnetic needle deflects in the compass. So later, now we are oning the switch, means we are oning the key. So if you on the key, what happens? The current will pass along the wire and it passes and it will make the closed circuit. By this what happens? The magnetic compass which has the needle in it, it will get deflects, means it will move at particular directions. Next, which force made to move this magnetic compass? So the conclusion is that if a current is passing through the wire, what happens? Around the wire their magnetic field will be produced. This makes the needle inside the compass to move. This is the case. Next, if you change the direction of the current, the direction of the deflection of the needle also changes. So now let's change the polarities of the battery or the switch. So by this what happened? We are changing the current direction. So previous, maybe the deflection will be towards the left side. If you change the polarities, what happens? The deflection will be toward the right side. This is the case. So by changing the current direction, we can get the deflections changing in directions. This is the case. Next, from this we can say that the current carrying conductor produces magnetic field. So this is our total activity. So we have shown if a current is passing through a copper wire the current which is passing through a wire, it produces magnetic field around it, which make the needle which is present in the compass to move it, means the deflections. This is the case. By this we have shown that the current carrying wire, though it is somewhat height, or though they both are separated with some gap, the magnetic compass needle is deflected due to the magnetic field which is produced by the current carrying wire. This is the case.